Here is the solving equations flowchart. This is not necessarily how you would want to solve every equation, but it does work for every equation. So sometimes there's other ways to solve that are easier, but if you followed these steps, you would always be able to solve an equation. So sometimes we first need to simplify an equation, and simplify is just making it easier. When you simplify, you have to simplify both sides. Usually they write it so we just have to simplify the left side and then right side's a number. When you simplify, you're following PEMDAS, or the order of operations. You worry about your parentheses, your exponents, divide and multiply from left to right, and add and subtract from left to right. So when we've learned about simplifying, the way we learned to simplify by multiplying was the distributive property. The distributive property. So this would be the multiply, or the parenthesis part. Then when we add or subtract to simplify, we combine like terms. Combine like terms. So here's an example of an equation. Before we can solve this equation, we want to make it easier. Right now it would be really challenging to figure out what number could replace x so that we get an answer of 32. But if we first distribute, then combine our like terms, it's going to get a little bit easier. So this right here looks like it can be distributive. So 3 multiplied by x and 3 multiplied by 5. We could use our rectangle. Put 3 here, x plus 5. Then we'd have 3x, 3 times 5 plus 15. Or many of you are just starting to use your arrows and knowing you have to distribute to each term. So 3x plus 5. Then we can rewrite all of this so we don't forget any of it. Plus 12 equals 32. So we finished all of our distributed, so we can move on to adding or subtracting, combining our like terms. Remember, to combine like terms, you have to have the exact same variables. So I see a 3x plus 2x. Whatever is right in front of the term is what you do. So 3x plus 2x is 5x's. Plus 5 plus 12, so plus 17. We can't combine it with those 32 because they're on opposite sides. So it would be like taking coins from this side and combining it with coins from that side. It just wouldn't make a lot of sense. They wouldn't be balanced anymore. So now we've made that a lot easier, and that's something we can solve. We'll move down to the solve part. When you solve this, when we've been talking about SAD map, or crossing out coins, different things like that, we use inverse operations. When you use inverse operations, remember to show your work on both sides of the equation. Otherwise, sorry, just one equation. Otherwise, your equation will be unbalanced. You will always do the inverse of what you see. You always do the opposite of what you see. So if you see add, you subtract. If you see multiply, you divide. So here are the steps. First, isolate the variable term. By variable term, that means like just a 3x, or just a y divided by -2. You isolate the variable term by adding or subtracting. So add or subtract first. Again, the inverse of whatever you see. Hi, Michael. Then isolate the variable. So if it was 3x, you want just x. Or if it was y divided by -2, you want just y. You do that by multiplying. So multiply or divide last. Multiply or divide last. Your solution should be variable equals constant. So x equals 1 or y equals -5. So variable equals some kind of number, you found your solution. So let's follow those steps with the equation we were working on. Let's see if I can put it to the side. So we want to isolate the variable term. The variable term in ours is 5x. So we're going to do that by adding or subtracting the opposite. So we have add 17. We want to subtract 17 from both sides. So those goes away. We have 5x equals 32 minus 17, 15. So now we have just a variable term equal to a constant. We want to isolate the variable by doing the inverse of what you see, divide or multiply. So we see multiply by 5, we want to divide by 5. 15 divided by 5 is 3. And of course we can check by going all the way back to our original equation and making sure we get the right answer. So instead of an x, I'm going to put a 3. Plus 2 times 3 plus 12, and I'm hoping I get 32 as my answer. So 3 plus 5 is 8, so I've got 3 times 8 plus 2 times 3 plus 12. So 3 times 8 is 24, plus 6 plus 12. Uh-oh, somehow I'm getting something too big. So I got 42. Looks like we better double check. When we subtracted, we got 15, we got 3. Oh, we forgot to distribute 15. Oh no. Good thing we checked our answer. So we put a 15 up there. Now when we combine like terms, we actually have 27 here. Now we can subtract 27, 5x equals 5. Divide by 5, so x equals 1. So now if we put 1 in here, we better make sure we get out 32. So 3 times 1 plus 5 plus 2 times 1 plus 12. So 3 times 6 plus, I'm just going to do 2 times 1 plus 12. 18 plus 2 plus 12. There's 20 plus 12. So 32. So x equals 3 was wrong, and x equals 1 is correct. Good thing we checked our answer.